In this video, we're going to look at how we can solve simultaneous equations. Just to explain why we need simultaneous equations and how it comes about. Supposing we have this equation, which is in terms of x, normally they are. Now I have 4x minus 3 is equal to 2x plus 9. How would we solve this? We would group the x's all the way on the left, so I have 4x. I will move the 2x from the right hand side to the left hand side. The sign changes, so it becomes minus 2x. And this will equal to, I'll take the minus 3 to the right hand side, becomes positive 3, so it becomes positive 3 plus 9. So here I'll get 2x is equal to 12, and x is equal to, we divide both sides by 2, 12 over 2, which is 6. So this is a simple equation with one unknown, and it is a linear equation in that the power of the variable x is 1. We don't have x squared or anything else. But now suppose we look at this example. I have a plus b is equal to 16. What values of a and b satisfies this equation? Well, you can easily see that there could be many. If I could put a equals 1 and b equals 15, which gives me a plus b is equal to 16. I can put a equals 3, b equals 13, which again will give me a plus b is 16. So I can have many pairs of a and b which satisfy this equation. So this equation has got two unknowns, but we have only one equation. This is where we need simultaneous equations. We need to have two equations to describe two unknowns to be able to find a unique pair of values for them. For example, if I have a plus b is equal to 16, as I have here, and say I have a minus b is equal to 8. Now here I have two equations, and I need to find values of a and b which simultaneously satisfies both of these relationships, both of these equations. So I know, because I set this question, that a equals 12 and b equals 4 will satisfy both equations simultaneously. So a plus b becomes 12 plus 4, which is 16, and a minus b is 12 minus 4, which is 8. So when we have two equations, two unknowns, if we have three unknowns, we would need three equations, and so on, as a general rule. Don't quote me on this. But how do we go about systematically solving simultaneous equations? This is what this video hopefully will help you learn. Okay, let's look at the same equations that we solved. I gave you the answer. A plus b is equal to 16. A minus b is equal to 8. How do we go about solving this sets of simultaneous equations? There's two standard methods that that we can use. One is called substitution, and the other one is called elimination. And this is the two techniques which I'm going to describe now. If I mark these equations as equation 1 and equation 2, in substitution, as its name implies, we substitute for one variable in terms of the other. Let us look at our equations above. Say if I take the equation number 1. From equation number 1, I have a plus b is equal to 16. If I make a the subject of the formula, I get a is equal to, I move b to the left hand side, becomes minus b plus 16. So I have a is equal to minus b plus 16. So now I will substitute this value of a in my second equation in number 2. So for a, I'm going to put minus b plus 16, and then I have a minus b there, which I have to write, and this all equals to 8. Now I have one equation, and I have one unknown, which is the unknown b. So to solve this, I have a minus b and a minus b. I get minus 2b. This will be equal to, I'll move the 16 to the other side. That becomes 8. The 16 coming to the other side becomes minus 16. So this becomes minus 2b is equal to minus 8. And dividing both sides by minus 2, I get b is equal to 4. Having obtained b, we know from this relationship up here that we said b is equal to, a is equal to minus b plus 16. So a will be minus 4 plus 16, which is 16 minus 4. So a will be 12, which is the answer we obtained earlier on. We could have as easily used the lower equation, equation number 2, to say a is equal to 8 plus b, and substitute 8 plus b in the first equation, and that would have resulted in the same answer. I will leave that for you to try. The second method that we use is called elimination. What we do here, if I write the equations down, that we'll have a plus b is equal to 16, and I have a minus b is equal to 8. I can see that I have a plus b here and a minus b here. So if I add these two equations, the b's will cancel. So if I add equations 1 and 2, let's call this here also equation 1 and equation 2. So if I add equation 1 plus equation 2, I will get a plus b plus a minus b is equal to 24. Here the two b's cancel. I'm left with 2a is equal to 24. So a will be 12. Once we have a value for a, we can substitute a in any of the two expressions 1 and 2, and we'll find b. So if I substitute a equals 12 into the top equation, I get 12 plus b is equal to 16. Therefore, b will be 16 minus 12 is equal to 4. So this basically is how we tackle simultaneous equations. I will do another example which might look slightly more complicated, but the same rules apply. Okay, here we have a set of simultaneous equations, 3x plus 2y is equal to 7 and x minus 1 is equal to minus 1. And we can solve this by either using substitution or elimination. I'll try to show you both techniques. And in an exam situation, you have to decide which one is easier to use or more suitable approach. Now, if I want to use substitution, that means I have to make x or y the subject of the formula. Now let's look at this. If I try to make y the subject of the formula above from equation 1, let's designate this equation 1 and equation 2. Now what would I write? I would write 3x plus 2y is equal to 7. Then I will write 2y is equal to 7 minus 3x. Then y would equal to 7 over 2 times 7 over 2 minus 3 over 2x. Now we need to then substitute this into the second equation and do a lot of algebra, and we will get the answer. However, the algebra will be more complex because we're using fractions and it just looks ugly. Anyway, take it from me. If we look at the second equation, we can see a much easier substitution that we can use there. So if I wipe this out, I can write x is equal to y minus 1. This is making x the subject of the formula. We could have easily made y is equal to x plus 1. I mean, it didn't matter. So I choose to do it x. You can try y. So when I have x is equal to y minus 1, I substitute this value of x in the first equation. So I'll get 3 times y minus 1 plus 2y is equal to 7. Opening the bracket, that will be 3y minus 3 plus 2y will be equal to 7. 3y plus 2y makes it 5y. And I'll take the minus 3 to the other side, becomes a plus 3. So I get finally 5y is equal to 10. And from here, y is equal to 10 divided by 5, which is equal to 2. So now that I have y is equal to 2, from this expression for x, I have x is equal to y minus 1. So x will be 2 minus 1 will be equal to 1. So this method that we used here, we used the method of substitution. That means we wrote one variable in terms of the other. So in this case, I chose x. X is equal to y minus 1. Then we substitute for x in the other equation the value we found here. So I've put 3 times y minus 1 and plus 2y is equal to 7. From there, we have one equation in terms of y. We find the value of y. We substitute it back in this equation that we have x equals to y minus 1, and it gives us our answer. Now, how would we solve this same question using the method of elimination? Let's do this in a different color. Okay, our equations were 3x plus 2y is equal to 7, and x minus 1 is equal to minus 1. Let's write it better, x minus y is equal to minus 1. What we need to do when we are trying to use the method of elimination is to eliminate one of the variables between the two equations. This is done First, by making the coefficient of both variables, of that particular variables, the same in both equations. Now, in equation 1, I have, let's call this equation 1, so that you know what I mean when I say equation 1. In equation 1, the coefficient of x is 3, and in equation 2, the coefficient of x is 1. So, if I multiply equation the 2 by 3, that means I multiply every term in the second equation by 3, then the coefficients of the x's would be the same. So I'm going to write the first equation as it is, 3x plus 2y is equal to 7. And I'm going to times every term in the second equation by 3. I get 3x minus 3y is equal to minus 3. Okay. Now, these two equations that I have, I will take away the bottom one from the top one. So we take the left-hand side of the top one is 3x plus 2y. And I take away from this a minus the left-hand side of the bottom one, which is 3x minus 3y. 3x minus 3y. And this will be equal to 7 minus 3. I'll write it here as 7 minus 3. Let's make a bit of room here. So if I expand the brackets and deal with like terms, well, I have 3x plus 2y, and I have minus 3x minus 3y becomes plus 3y. Here I have 7 minus 3, which becomes 7 plus 3, which becomes 10. Now the 3x and minus 3x, they cancel. So I have here 2y plus 3y is equal to 10. So I get 5y is equal to 10. And from here, y is equal to 2, which is the same as we found in the other equation. Once we have one of the variables, we can substitute it. We can substitute it in any of the equations 1 and 2 to find the variable x. Here, if I put y equals 2 for x in the second equation, I have x minus y is equal to minus 1. I substitute for y equal 2, I'll get x minus 2. This x doesn't do very good again. X minus 2 is equal to minus 1. So x will be equal to minus 1. I'll take minus 2 to the other side, becomes plus 2. So x becomes equal to 2 minus 1, which is 1. So our answers in both cases is x equals 1 and y equals to 2. So on the right hand side here we had the elimination, and on the left hand side we did by substitution. To recap the process of elimination, what we need to do is to make the coefficients of one of the variables in the two equations the same. In this case we had the coefficient of x, we chose to make the same. We could have easily chosen the coefficient for y to be the same. So I have the first equation. The first equation, I have 3x plus 2y. Second equation, I have x minus y So if I know if I can make this x as 3x, then I can take away from the 3x in the top equation and I can eliminate them. So the way we've done it, we systematically write the first equation, 3x plus 2y is equal to 7. We multiply every term in the second equation by 3, which means I get 3x minus 3y is equal to minus 3. Then I subtract the lower equation from the top equation. I've done it here in bracketed form so that it's clear. And with a bit of algebra, we will arrive at this equation in one variable, which is in terms of the variable y. So we find y is equal to 2. And when we have y, we can substitute this in any of the original equations to find the value for x. I hope this has been useful. Please give this video a like and subscribe. And I will show you in the next video what does simultaneous equations mean geometrically, so that we have a visual method of seeing what is happening when we are solving simultaneous equations. See you in the next video.